Welcome to PIC Computer Science video number 103, where we look at data handling. Now, this is quite an expansive little area that we need to look at. When it comes to data handling, the exam board says that we need to know different methods of capturing data, selecting data, managing data, and exchanging data. So, firstly, we'll look at the first sort of stage, which is the capturing of data. Now, traditionally in computer systems, we would first have somebody fill out a form that might look a little bit like this or like this, using paper and a pen or a pencil, and this is known as a DCF, a data capture form. It's paper based, and then somebody would take that paper based filled out form and enter those details into a database on a computer using input devices such as keyboards and mice. If we think back to when we looked at input, storage and output devices, and input devices in particular, we might remember there's such an input device as an optical character recognition scanner, which performs OCR, optical character recognition. So forms like this could be scanned in to a piece of hardware, an OCR scanner, and that hardware, along with some software, would be able to recognize characters and put those automatically into a database. So that would take out the step of a human being having to input the data, copying it, transposing it from a paper-based form into the database. A machine could do it. And there's also a technology which has a similar name called OMR, optical mark recognition, where again a data capture form, albeit a simpler data capture form, could be used, where multiple choice questions are completed, usually by filling in a circle or a box or putting a line across a box, and then again some sort of OMR scanner would scan in those readings and pop those values into a database. OCR and OMR are almost semi-automatic ways of capturing data. A fully automatic way would be the use of some sort of sensor which logs movement or measurement in some way. Weather forecasting systems are a good example of this. This is an example of a motion sensor that would pick up motion and record that in a database before performing some sort of output, as demonstrated in the diagram. And that would be deemed being a more fully automatic way of capturing data. When it comes to actual qualitative data that we wouldn't be able to collect with semi-automatic or even fully automatic data capturing methods, we tend to now use web forms where we don't involve the step of a data capture form, a paper-based data capture form. Somebody would put their details directly into a database, typically using a web page and a form on a web page as shown in the screenshot there. So this again would be done with keyboards and mice, or quite often now using on-screen keyboards and touchscreens on devices like tablets and smartphones. So that was capturing data. Now on to managing data. And to think about this, we really need to have a little bit of a history lesson in the evolution of databases. When storing data on computers originally, we might use what is called a serial file. So this might be data that is stored in a simple file, such as a text file, and is entered in a serial fashion, meaning that the first record is entered, then the second record is entered and is put after the first, and the third goes after the second, and data is stored in the order that it was entered. So we can see these are in no particular order, these people, other than the order that they were entered into this file. Then came along sequential files, which were a bit of an improvement on serial files, because new data could be added to a text file, but then put into some sort of sequential order. So when the new record was added, the correct place would be found for it, and that would be dependent on some sort of key field, so the same concept as a primary key. So if we look at this example, we should be able to spot that the key field for this sequential file is the person's second name, their last name, and so it's stored alphabetically. So when Jatish Mystery was added, they were put into the right place rather than just bunged on the end. A further development on this was the indexed sequential file, where data might be prefixed with a category. So why this might be useful is if we were looking up, say, Scott Hills, we could know that he's going to be in the H to M category of surnames, so we can skip the A to G's when searching, and we know he's going to be somewhere in these three records, the H to M's. So this allows for faster searching. The slowest searching would be serial files, because you'd have to look through all the data until you found the record you were looking for. Sequential would be next fastest, because you know what order data is in, but even faster would be something that's indexed, where you can jump to a particular index within the file. You can find out more about these types of files and others as well in the following PIC Computer Science video, so make sure you watch that. So after these simple files such as serial and sequential, etc., which would probably be stored in what we call CSV format, comma separated value format, and you should be able to see why they're called those, we then got our flat file databases, which had more structure and maybe had a bit more of a table format, such as a spreadsheet. And after that, we got our relational database, and our relational database will be stored in something called a DBMS. So what is a DBMS? Well, DBMS stands for Database Management System. Or we might even see the term RDBMS, which is Relational Database Management System. A DBMS is software that handles the complexities of managing a database. This software may provide a user interface, and most do, and it may use something called SQL to communicate with other programs. It can provide different views of data for different users, and includes something called the data dictionary, which we'll look at more closely in a moment. Tasks that a DBMS performs, including finding data, adding new data, updating existing data, maintaining indexes, enforcing data integrity rules, managing access rights. Popular DBMSs that you might well use will include Microsoft Access, Microsoft SQL Server, which is a more industry standard DBMS than Access, and then free DBMSs such as MySQL. Now, the data dictionary is an integral part of the DBMS. It is a file containing descriptions of the data in a database. It's used by database managers when altering the database structure, and it uses metadata to define tables. So what does it store? It stores the names of tables and columns, the characteristics of data such as their data type and the length of the data in each column or field. It puts on restrictions onto values in columns. So by that we might mean validation. It stores the meaning of data columns, so you might be able to describe what is actually stored in a field. It stores those relationships between data that we've seen, and stores lists of which programs can access data. So for example, can Visual Basic access some data in an Access database? It identifies primary keys, foreign keys, indexes, and defines access rights, so which users are allowed to view which bits of data in which databases. Other terms that we might come across when we're thinking about managing data include referential integrity. Now, we just talked about the DBMS managing the integrity of data, and referential integrity is all about managing the integrity of relationships, and so we don't end up with things like orphaned records, but more about that in your second year, as with transaction management, which is all about who can change which records and at which times if you've got multiple users accessing a database. Now, selecting data is a very important part of data handling. Involved in selecting data are queries, and queries are questions used to retrieve selected information from a database. and if you watch this Pick Computer Science video, number 105, the video goes into detail about how to set up a simple query in Microsoft Access. But you'd have to try out some for yourself and get a bit more advanced at them. There's loads of videos on the internet telling you how to create all sorts of different queries to show particular records. Selecting data is also to do with something called reports, which is the presentation of selected data from a database. So usually you have a database query where you want to make the results look a bit more professional, and you might want to show summaries of results, etc. And that's achievable with reports. So there's a video on that there in video 106. Selecting data might also be to do with something called views, and views are how particular types of user see data. They can be set up so that they contain only the data that a user needs for their job. Some people might think of views being forms within databases, but they are not strictly so. More accurate is that a view of data is a query, but a query that can be updated by users, where the data in the underlying tables can be updated by users. Now these can be set up in Microsoft Access, but to do so you need to know a bit of this thing that we keep talking about, SQL. So we'll look at views another time, and we'll look at the SQL that you need to know for that for another time. SQL is a second year topic. Finally, the exam board say we need to know about exchanging data when it comes to data handling. Now I'm not too sure exactly what they mean by this. Maybe they mean possibly the emailing of reports, so the results of a query nicely professionally presented and sent via email maybe to a customer or a colleague. They might mean the uploading of such reports to the web ready for download by other people. They could possibly mean the integration of systems to exchange data. Lots of systems and databases that underpin systems are linked. For example, if we think about a college where the user might log on to Windows using a particular database, and that database is then linked to a college's VLE database. So the person who's logged into Windows is automatically logged into the VLE, and it loads up their VLE account, and likewise with other such systems. So databases all around the world are all interlinked, so they might be touching upon that, so it would be good to do a bit of reading around that. Maybe they just mean the allowing of external users to log into web-based databases. So Facebook is a massive database of information which lots of different people can log into and use and see. So maybe they mean that. Maybe they mean exchanging data as we go into the next topic, which is networks and the exchanging of data from computer to computer. So maybe it's just a nice way of saging into that particular unit. Hope that was useful. There's a lot there to consider, and if you've got a good overview of it, then you should do quite well.